In this lesson, we're going to be discussing eigenvalues and eigenvectors. And so we're going to be finding the eigenvalues and eigenvectors of this given matrix. I want you to support me by subscribing to this channel, like the video and share with your friends. Also, don't forget to comment. That's the only way you can encourage me and motivate me to make more videos. Thank you. So let's find the eigenvalues and eigenvectors of this matrix. So the formula for eigenvalues is determinant of A minus lambda times identity matrix, then equal to 0, where this matrix A is a square matrix of the order n by n. So with this, it can be a 2 by 2 matrix, a 3 by 3 matrix, a 4 by 4 matrix, and the rest of them. So this lambda is the eigenvalues that we are looking for. It's a scalar, and then this I here is the identity matrix, which would be the order of this matrix A. So if this matrix A is a 2 by 2 matrix, this identity matrix will be of the order 2 by 2. So if this A is a matrix of 3 by 3, this identity matrix will be of the order 3 by 3, and so on. So after on, we are going to equate it to 0, which is this 0, and then solve for the value of this lambda, which is the eigenvalues. So after equating it to 0, the equation we're going to get is going to be the characteristics equation of this matrix. So without wasting much time, let's dive into the question and solve it. So we have determinant of, now matrix A is 2, 3, 4, 1. That's the elements 2, 3, 4, 1, and then minus lambda times identity matrix of the order 2 by 2, which is 1, 0, 0, and 1. Then let's close the determinant sign. Then this is equals to 0. So this is going to be, so we have 2, 3, 4, and 1. Then minus lambda times 1 is equals to lambda. Lambda times 0 is equals to 0. Lambda times 0 is equals to 0. Lambda times 1 is equals to lambda, then equals to 0. So we are going to have 2 minus lambda. So let's open another matrix distance. So we have here 2 minus lambda, then 3 minus 0 is equals to 3. 4 minus 0 is equals to 4. Then 1 minus lambda is equals to 1 minus lambda, then equals to 0. Now let's find the determinant of this matrix. So it's going to be 2 minus lambda times 1 minus lambda minus 4 times 3. So when we simplify it, we are going to have 2 minus lambda multiplied by 1 minus lambda minus 4 times 3 is equals to 12. Then this is equals to 0. Then 2 times 1 is 2. 2 times negative lambda is negative 2 lambda. Negative lambda times 1 is negative lambda. Negative lambda times negative lambda is plus lambda square. Then minus 12 equals to 0. So 2 minus 12 is equals to negative 10. Minus 2 lambda minus lambda is equals to minus 3 lambda. Then plus lambda square equals to 0. Now if we rewrite this equation, we're going to get lambda square minus 3 lambda minus 10 equals to 0. Now this equation is the characteristics equation of this matrix. So we're going to solve for the value of lambda in this equation using factorization method. So let's open two parentheses, equate it to 0. Since the coefficient of this lambda square is 1, we are going to write lambda here and then lambda here. So we find two numbers so that when we multiply them we get negative 10, and when we add them we get negative 3. So those two numbers are negative 5 and positive 2, because negative 5 times positive 2 is negative 10. Negative 5 plus 2 is negative 3. So we now go to have lambda minus 5 is equals to 0, or lambda plus 2 is equals to 0. So when we add 5 to both sides here, you have that lambda is equals to 5. Then when you subtract 2 from both sides here, you have that lambda is equals to negative 2. And so you have that lambda is equals to negative 2 or 5. So these two values of lambda here are the eigenvalues of this given matrix A. So from these two eigenvalues here, we're going to find the eigenvectors of this matrix. So let me rewrite the eigenvectors here. Lambda is equals to negative 2 or 5. Now for the eigenvectors, the formula is matrix A minus lambda times identity matrix multiplied by x equal to 0, where this A is a square matrix, just like the formula in eigenvectors. Now this lambda here is the eigenvalues which you have found. This I is the identity matrix, which is of the same order as this square matrix A. Then this x is a column matrix, which is the eigenvectors. So we're going to be writing it as x1 and x2, since this is a 2 by 2 matrix. If it's a 3 by 3 matrix, then it will extend to x3. Now this 0 also is going to be in a vector form of just like this x, so it's going to be 0 and 0, since we are dealing with a square matrix. So it's going to be in a vector form instead of just scalar form like a single 0. So let's go ahead and find the eigenvectors of this matrix. So when lambda, which is the eigenvalue, is equals to negative 2, we're going to find its eigenvectors. So we're going to have this matrix A, which is 2, 3, 4, and 1. Let's not forget to open a bigger bracket. Then we have minus, then lambda, when lambda is equals to negative 2. So we replace lambda here with negative 2. Then multiply by identity matrix, which is 1, 0, 0, and 1. Multiply by the eigenvectors, equate it to 0. So let's simplify this left hand side. I have 2, 3, 4, and 1. Then minus times minus is plus, so you have plus 2 here. 2 times 1 is 2. 2 times 0 is 0. 2 times 0 is 0. 2 times 1 is 2. And let's close this. We have x1 and x2 then equal to 0. So let's perform this operation here. This matrix plus this matrix. So we're going to have 2 plus 2 is equals to 4. Then 3 plus 0 is equals to 3. 4 plus 0 is equals to 4. Then 1 plus 2 is equals to 3. Then this multiplied by x1, which is the eigenvector, and then x2, then equals to 0. So let's perform this multiplication. So 4 times x1, you have 4x1, then plus 3 times x2 is equals to 3x2. Then this is equals to 0. Now we're not going to multiply this second row, because this second row is linearly dependent on this first row. So even if you multiply it, you're still going to get the same equation as 4x1 plus 3x2 is equals to 0. So here, let's make x2 subject to the formula. When we make it, we have that 3x2 is equals to negative 4x1. If we divide both sides by 3, this and this will cancel. We have that x2 is equals to negative 4x1 over 3. So when x1 is equals to 1, we're going to assume that x1 is equals to 1. Then x2 will be equals to negative 4 over 3. So we can say that the eigenvectors when lambda is equals to negative 2, or when eigenvalues is equals to negative 2, is equals to, now x1 is 1, and then x2 is negative 4 over 3. So, but this is a fraction. We want everything here to be whole number. So to remove this fraction, we multiply everything here by 3, so that the final answer of this eigenvector will be 3 times 1 is equals to 3, and then 3 times negative 4 over 3 is equals to negative 4. Alright, so this is the eigenvector when eigenvalue, which is this, is equals to negative 2. So let's solve for eigenvectors when eigenvalue is equals to 5. So when eigenvalue is equals to 5, using the same formula, we have that matrix A, which is 2, 3, 4, 1, minus when lambda is equals to 5. Then we have identity matrix of 1, 0, 0, and 1. Now let's not forget this big parenthesis. Then this is multiplied by x1, x2 equals to 0. Then we have 2, 3, 4, and 1. Then minus 5 times 1 is 5. 5 times 0 is 0. 5 times 0 is 0. 5 times 1 is 5. Then let's not forget the big bracket. And then we have x1, x2 equals to 0. So let's perform this operation, this matrix minus this matrix. We're going to have 2 minus 5 is negative 3. 3 minus 0 is 3. 4 minus 0 is 4. 1 minus 5 is negative 4. So all of these multiplied by the eigenvectors and equals to 0. So let's multiply this matrix and this matrix. So minus 3 times x1 will give us minus 3 x1. 3 times x2 we have plus 3 x2, then equals to 0. Now we're not going to use this second row here because this second row is linearly dependent on this first row, so it will still give us the same thing. So let's make x2 separate for the formula. When we do that, we will have 3x2 is equals to 3x1. So let's divide both sides by 3. This and this will cancel, and then we'll have that x2 is equals to this and this will also cancel, so x2 is equals to x1. Now when x1 is equals to 1, you have that x2 is also equals to 1. So the eigenvectors when lambda is equals to 5 is giving us 1 and 1. So this is it for this video. So thank you for watching. Don't forget to hit the subscribe button, like my video, comment, and share with your friends.